Good morning, y'all. Today we're going to look at literal equations. We've done these twice before. We want to review them for you. Make sure you remember how to do them. So we've shown you how to do the do-undo table. We've also shown you how to solve these using SAD-MEG, which is just order of operations backward. Your parentheses, the P in PEMDAS, it doesn't just stand for parentheses. It also stands for any grouping symbol. Parentheses, braces, brackets, square roots, fractions, absolutely anything that groups numbers together. So to solve any equation, whether it's full of numbers or full of letters, you're just going to do order of operations backward. So for a little recall, if we want to solve for y, do your order of operations backward. Do you see any subtraction? No. Do you see any addition? Yes, we see that 3x is being added to that 5y. We don't touch our y. This is what we're solving for. So we want to subtract the 3x. Get that away from y. So move it over to the other side. And then what's happening to y? Do you see division on y right here? No. Do you see multiplication? Yes. This is being multiplied by 5, so we're going to divide it out. Now you can divide it by the whole thing, or you can split it up into little fractions and divide it like that. So you'll get negative 3x over 5 plus 3 over 5. And that'll give you your slope and your y-intercept. I'll write that just a little bit better. That x shouldn't be all the way up there. There you go. You can do the same thing if it's just letters, if there's no numbers. You're still solving for y. So what do you see with y? Let me erase this. So SAD-MEG. Do you see anything being subtracted from y? No. Do we see anything being added to y? Yes. To y, we are adding ax. So we want to do the opposite. We want to subtract ax. So you'll have by left over, and then we just have this c minus ax. Then what else is happening to y? Do we see division on y? No. Do we see multiplication? Yes. This is b times y, so we divide b out. And again, you can make it one big fraction. So this can be c minus ax over b, or you can split it up into little fractions and put c over b minus ax over b. Either one of these are perfectly correct answers. Okay, so let's try one that's not y equals mx plus b. Let's look at c. We're still solving for y. So what is happening to y? So if I do my SAD-MEG again, SAD-MEG, order of operations, backward. Do you see subtraction on y? No. Do you see addition on y? Yes. For y, we are adding r squared. So we want to do the opposite. We want to subtract r squared. Now, a big R and a little r, these are not the same thing. You cannot combine those. Also, you can't combine them because one of them has an exponent, so they're definitely not the same thing. So just write them out. So what else is happening to y? We just did addition. Is there division on y? Yes. Fractions are just division. This is y divided by s. So we do the opposite. What's the opposite of dividing? Multiplying. So we multiply that s to the other side. It gets multiplied by everything. So let me erase this so I can have space. So you're just going to have y left over, and then you're going to have this phrase, this s times r minus r squared. You can leave it like this. Occasionally you'll see it on your test where it gets distributed out. So s times r is sr, s times negative r squared is negative sr squared. Again, both of these are perfectly fine answers. You can leave it either way. So some quick notes to review when we solve, how we solve literals. Remember to find the variable that you're solving for. Underline it, circle it, highlight it, whatever you need to do so you know I don't need to mess with that letter if at all possible. There are very few cases where you actually mess with that letter. You're going to treat everything else like a number. You can add everything else, you can subtract it, multiply it, divide it, distribute it, whatever. You can do anything you need to the other letters. On each specific side, you have to ask yourself, should I use distributive property or factoring, the snowflake? Should I do one of those? You should only ever do those if it makes it easier. If it doesn't make your problem easier, don't do it. So don't do distributive, don't factor, or in some cases a GCF. Don't do those if it makes your problem harder to solve. So for instance, if we have, there we go, x times mr minus n equals 3. If I want to solve for x. If I were to distribute this, that's going to give me 2 x's. I cannot solve an equation if I have 2 x's. I can only solve for x if I have 2 x's. I can only solve for x if there's 1 x. So in this case, distributing would not be the best idea. And I'll show you how to get around that in just a second. When you look at both sides together, you need to think, should I add or subtract a variable to the other side, like we did up here, where we subtracted 3x to the other side, we subtracted ax, we subtracted r squared. Should I add or subtract? Should I multiply or divide to remove a number or clear a fraction or anything like that? Exactly like we did up here. We divided by 5. We divided by b, and on the last one we multiplied by s. Then, should we take the square root to remove a square? If you have x squared, the only way to solve for x is to take the square root. That'll cancel it out. And if you do that, you have to take the square root of everything. Should we square to remove a square root? Yes, if you have square root of x, and you have to solve for x, the only way to get rid of this square root is to square the entire equation. That'll cancel it out and leave you with x. And then, can it be written different ways? There are some equations that can be written a lot of different ways, like we saw up here. Sometimes we can leave our fraction as one big fraction, like we did here. Sometimes we can split it up. Sometimes we can leave it in parentheses. Sometimes we distribute it. Same thing we're showing you down here. You could distribute this 2 out, or you could take a GCF of 2 out of it. That's how we get this. If you have a really big fraction, you could split the fraction up into 2 smaller fractions, whether it's plus or minus. So there's a lot of different ways you can write these equations and a lot of different ways you can solve these equations. So let's try some more. So for example A, we want to solve for n. So I'm going to highlight n. Oops, that's not the right thing. That's what I'm solving for. I don't want to touch that letter if at all possible. I don't want to move it or do anything to it. So this one has distributing. Can we distribute this? Like I was telling you before, if you distribute this, you're going to get n over 2 times q and n over 2 times p. That's going to give you 2 n's. We're trying to solve for n. We don't want to create more n's. We only want there to be 1 n. So we should not distribute this. That's not going to make this problem easier. It's going to make it worse. So then what do? Well, let's just go to SAD Meg. Do we see subtraction? No. Do we see addition? Yes, but that addition is within parentheses. I have not made it to grouping symbols yet, so I can't work with that. Grouping symbols are the very last step. So no addition outside of a grouping symbol. Do we see division outside of a grouping symbol? Yes, we have n divided by 2. How do we get rid of division? We multiply. So we're going to multiply by 2 to the other side. 2 times m is 2m. That'll leave us with n. So that's our division. So we're still solving for n. So do we see multiplication on n? Yes, this is n times that whole parenthesis. Now we just talked about we could not distribute this. That would cause us to have 2 n's, and we can't solve it if there are 2 n's. So how do we get rid of multiplication? We divide. You can divide out this entire parenthesis all at one time. That'll cancel it out and move it to the other side. That'll leave you with n, and just bring this over. Don't change anything about it. You have 2m on top. You're dividing by that big old parenthesis. N's finally by itself, so this is our last step. They're not going to be pretty. Most of these are going to be very ugly answers. But all you want to do is get n by itself. Get everything else away from it, doing whatever you can, following your order of operations backward. So B, we're solving for x. So what's happening to x? So if I do my SAD Meg, do we see subtraction? Yes. However, like I told you on the last problem, this is inside of a group. I'm not to grouping yet. That's the very last step. So I can't do that just yet. So I can't work with that subtraction. Do we see addition? No. Do we see division? No. Multiplication? Yes. This is 2 times that square root. So how do I get rid of multiplication? I divide. Divide out the 2, and it moves to the other side. Okay, do I see an exponent? No. Do I see a grouping symbol? Yes. That square root is a grouping symbol. How do I get rid of a square root? Go back to your notes up here. You're going to square it to remove a square root. So you're going to take that whole side and square it. That'll cancel it out. But we also have to do it to the other side. What you do to one side, you have to do to the other. So that'll leave us with x minus y. And we got w over 2 squared. Now you could simplify this out if you would like. This is just w squared and 2 squared, so w squared over 4, if you want to simplify that out. Sometimes they do, sometimes they don't. So just watch whatever your answers say. Okay, we're still solving for x. So I just did my grouping symbol, so now I just start over. Do I have subtraction? Yes. We have minus y. How do we get rid of minus y? We're going to add y. Add it to the end. So that'll leave me with x equals, and then your w over 2 squared plus that y. Or if you want to simplify it out to w squared over 4 plus y, that one's fine as well. Either of these work. I'm not exactly sure which one shows on your lesson, I can't remember, but both of these are correct. Okay, what about C? So for C, we have a equals v minus u over t, and we want to solve for t, so this bottom number. So let's see what we can do. We have sad meg. So do we see subtraction? Yes, but again, it is grouped at the top. We can't do that group yet. That's the very last symbol. The very last letter. So we can't do grouping just yet. So skip that for now. Do we have addition? No. Do we have division? Yes. This is v minus u divided by t. So how do we get rid of division? We multiply. You always multiply what's on the bottom. This is the one case where you're going to move the letter that you're solving for. You have to move it to get it out of the denominator. That's the only way to do this. In any other case, you would not touch that variable. But to get it out of a fraction, to get it out of the denominator of a fraction, you're going to have to multiply it out. So t times a is ta, and just bring down the rest. Okay, so that was our division. So now our t is on the other side. So with that t, do we have multiplication? Yes, we have t times a. So how do we get rid of multiplication? We divide. So t equals, just bring this down, v minus u over a. T is by itself now, so we are done. Just get t by itself. Okay, for D, we want to solve for R. So we're going to solve for this little r right here. So we got our sad meg. So on R, do we see subtraction? No. Addition? No. Division? Yes. Fractions are just division. This is 1 divided by 3. So how do we get rid of that? We multiply by the denominator. So multiply out a 3 to the other side. So 3v. You can bring down that 1 pr squared h. You don't technically need ones. Ones are understood, like 1x and x are the same thing. You don't have to have ones. So I'm going to drop it because we don't need it. So that was our division. Do we see multiplication? Yes, this is p times r squared times h. It's being multiplied by two things, so we're going to divide both of those out, p and h. That'll leave us with r squared, and just bring this side down. We're still solving for r, so what else is on r? Do we have exponents? Do we have exponents? Yes, we have a squared. How do we get rid of a squared? Well, again, go back up to your notes. Take the square root to remove a square. So we're going to square root this side. it'll get rid of the squared and leave us with r. And we square root the other side.
Juniors and seniors class change.
So we square root the other side and just bring it over because we don't know the square root of any of that. When you take the square root, it also has two answers, so you're going to have a positive and a negative. I believe your answer choices have that in front, so make sure you remember that. And then r is by itself, so that is it. Take two more examples. We have e over here, so we want to solve for b. So right here. So what can we do to b? So let's look at Sad Meg. So do we have subtraction? No. Addition? Yes. We are adding a squared to b. So how do we get rid of it? We do the opposite. The opposite of addition is subtraction. So subtract it out. Do we have division? No. Multiplication? No. Exponents? Yes. You have a squared here. So how do I get rid of squared? I'm going to square root it. That'll cancel out the squared. One second. No, I'm recording a video. Come back later. Sorry about that. Okay, so to get rid of your squared, you're going to square root. That'll leave you with b. Now these squares over here, they're not going to go away. You can always test this out in your calculator by just plugging in numbers. So I'm going to say c is 3 and a is, let's go 5. Actually, let me flip these around because that'll give us a negative. So I'm going to say c is 5. I'm going to go 7 and 5. So go 7 and a is 3. I like that better. So you can pick any numbers. I just happen to like 7 and 3 better. So if I take 7 and 3, if I have the square root of 7 squared minus 3 squared, that's going to give me one answer. We can test that out. So the square root of 7 squared minus 3 squared, that's going to give me some long decimal, 6.32. If I were to cancel out these squareds and say that was just c minus a, well, 7 minus 3 is 4. Those are not the same thing. So canceling out those squareds does not give you the same answer. So we can't do that. We have to leave the square root and squareds there. So this is not c minus a. This is still going to be the square root of c squared minus a squared. And again, anytime you take a square root, you're going to have a plus and minus in front because it's going to have two answers. So do not cancel that out. The minus sign is what messes that up. That's why you can't cancel out the squared. Okay, and f, we want to solve for b. This time, it's a little different. We have two b's right there. So we've talked about this. We can't solve it when we have two b's. So how do we solve it? This is where you're going to take a GCF. Both of them have b's, so we're going to take a b out. That'll leave us with a minus c. Just take the b out front. Okay, then we do our Sad Meg. So do we have subtraction? Yes, but it's inside a grouping symbol. We're not two grouping symbols yet, so we can't do that yet. Does it have addition? No. Division? No. Multiplication? Yes, this is b times your whole parenthesis. Now, would you distribute this? No. If we distribute this out, we're just going to get AB minus BC. That's exactly what we started with. And we couldn't solve that.
Sophomore class range.
So what do? How do we get rid of multiplication? We divide. Just like that last problem on the previous page. You can take that entire parenthesis out at one time. So it'll go away, leave you with B, and we'll just bring this side down. CD over A minus C. B is by itself, so we are done. So y'all try the rest. Remember SAD-MEG. And if you ever have two of the same variable, you want to take them out with a GCF. Just bring it out front, leave everything else in parentheses. SAD-MEG will get you through every single problem. Just remember, if it's in a grouping symbol, you cannot do it until the end of the problem. Good luck.